I promise you that you don't necessarily need to have dependencies in Golang to build a really powerful web server. And honestly, it's quite easy to do as well. The newest Golang version brings a lot of new shiny additional enhancements to the HTTP module, which allows to easily create web servers in Go. Therefore, we are going to test this specific HTTP module to build a web server from scratch without any third-party dependencies. Oh, and by the way, if you're new here, my name is Flo, I'm a professional software engineer, and on this channel we do everything related to the software engineering world. Now, like I said before, we are going to implement a web server from scratch in Golang without any third-party dependencies. And it's important to note that we are going to build capabilities of like retrieving, adding or deleting of a user from a database. Now, it's important to note that we are not going to connect our web server, for now at least, to a real database like SQL. We're just going to make use of a really simple in-local memory key value store to simulate the database. But you can pretty much feel free to enhance this web server on your own. So let's get started. So what we got here is a pretty plain, simple Golang project, and we're going to start here from scratch, like I said, right? And the first thing we're going to need is a so-called MUX. Now, a MUX is something like a request multiplexer, which allows you to kind of control the traffic to specific endpoints or handler functions. Now, what does that mean is that pretty much the multiplexer just handles the traffic for you and just redirects the route to the correct handle function. So let's create this one here. Now we are going to start with just MUX, and then we are going to make use of the net HTTP module. And here we are going to say new serve MUX. Now this, like I said before, creates a new request multiplexer. And now we can also create our handle functions. So for that, we are just going to say mux.handlefunc. And now this allows you to define a pattern, and whenever the user goes to this specific pattern, so it might be just a slash, the root page of our server, then this specific handler function gets called. So it, like I said before, the multiplexer just controls the traffic. So let's start here with a really simple root endpoint, and we are going to create this handler in a different function. So for that, we are just going to say handle root. And then obviously we are going to need to create this handle root function. And generally this handler function takes in two parameters. The first one is the response writer. So we just say W, for instance, and then we say http.responseWriter. And then we also have the request itself, which is just a pointer. Now these two parameters are really important to kind of configure or handle the endpoint. So for instance, the response writer is responsible for constructing a response for the client, so that we can say, for instance, that the response is here of status code 200 or 44. And the request itself basically contains all sorts of information of the request, which kind of makes sense, right? So for instance, the body, different headers, or for instance, the URL of the request. And for now, we are just going to say fmt.printf, and then we are going to say w, because we are making use of the response writer here. And here we are going to say hello world. Now it's important to know that it's not printf, it's actually fprintf. Now, and fprintf is a really generic function that allows us to kind of write anything we want to a response writer or to a writer in general. Because in the end, let's just inspect this fprintf function. This fprintf function just wants a IO writer interface in the beginning. And because our response writer implements the IO writer interface, we are able to use the W, so the response writer here in the fprintf function. And obviously our server, so our request multiplexer, has not been started yet, right? So the server kind of doesn't exist yet. So let's just create this one. And for that, we can just make use of the HTTP listen and serve functionality here. And this is, I think, pretty straightforward as well. all it expects is the address. So we can say, for instance, just defining the port, and Go, or the HTTP module, basically knows with that we want to address the local address, so localhost in this case. And the handler is an HTTP handler, which in this case is just our request multiplexer. So we can just say mux here. And now our server starts. Now obviously we want to kind of print a beautiful message before that. So let's just say fmt.println. And here we're going to say server listening to 8080. Right, let's just start this server. And what we see is that our server is listening to 8080. Now what we could do is just go to Postman or make a simple curl request to this localhost 8080 endpoint, and then we will get our hello world back. So let's quickly do this. Let's just say that we have a new terminal, and in this terminal we're going to say curl localhost 8080. And there we go. We basically now get our hello world response back, defined by our handle root handler function. Let's create a new handler function, and now we are going to actually start with our post request. So we want to create a user, and therefore it has to be a post request. By definition, obviously. Obviously, we could just use delete, for instance, as well, but the specification says that create should be almost always a post request. So let's use handle func in this case, and then we are just going to say in a string post, and then we are going to say /users. And that is basically it, right? With that kind of syntax or kind of pattern matching technique here, we are just going to say that the handler function should be a post request. So this handler function should respond to all sorts of post requests related to this endpoint. And then we're going to say the handler function is named create user. So let's quickly create a function here called create user. And obviously we have to take in the two parameters here again. So our response writer and our request. And now we can start with our user creation. And like I said in the beginning, is that we want to use a local in-memory database or some sort of cache that we can make use and to simulate this database. So let's quickly create this up here. And we are going to say, let's just say user cache, for instance, and this is obviously a hash map or some sort of map that we can use that basically maps an ID to a user. So we just say map int and then user. Obviously we need to create this struct, so let's just do this here. We just say type user struct, and then we say name string. And here obviously because we want to, for instance, send a response back in JSON format, we need to kind of define a JSON tag which maps this name to a valid JSON representation. Because in the end, if we just have a JSON response where the name is capitalized, it's not valid JSON, right? So with that in mind, we can just use these backticks here. And then we can say JSON and then we say name. So it's basically the lowercase version of our name. Alright, that's pretty nice. Let's go back to our create user function. And then we are going to just create an empty user struct here, right? This is how we just declare a user, but we didn't initialize the user yet. The reason for that is that we obviously want to retrieve the user data from the request, right? And that's where our HTTP request comes in here. So we can just say json.newDecoder, and then we say r.body, and in here we need to make use of the decode function, where in the end we're just going to say user. So we are going to pass in the memory address of our newly created user struct here. And all it does here is just creates a new decoder based off our kind of body in the request, which just contains the information of the user. And in the end, we are going to decode this information, which comes from the request, to our user. So that in the end, this user here contains all of the information we've specified in our body. Now, obviously, this body has to match with our user struct, and that's why we've also used the JSON tag here. So let's just use error, because obviously this can return an error. So for instance, there could be some decoding issues maybe. And for now, we are just going to check if the error is not equal to nil. We obviously want to return, so we don't want to proceed with our logic here. And then we are going to say http.error, and here we make use of the response writer. Then we need to define the error and then the code. And in the end, we are just going to make use really of the error from our decode error here. And then we are just going to say http.bad_request. And the reason why it is a bad request is pretty simple, because our decoder can, like I said before, throw issues when there is like a decoding or formatting issue of our JSON. And for instance, if the name does not even exist in the JSON request, then obviously it is a bad request. So after that, we can just double check here if the username is not equal to nil. So if the kind of username is empty, then we obviously also want to throw an error, because we don't want to insert a new user with an empty name. So we're just going to say return, and then we can copy the bad request error from above. And here we can say, instead of using the error directly, we can just say name is required, right? Pretty simple, pretty easy. All right, and in the end, we are just going to say write header, and we are going to make use of the no content status, which in the end is just the 204 integer here. Now obviously you can enhance this specific endpoint by just returning the response of the newly created user, but I'm going to keep it really simple. And obviously we're going to need to insert this user in our local memory database. So let's just quickly do this by simply saying user cache, and then we need a new ID, so we can pretty much just get the length of our user cache and say +1 here, and then we are going to assign the user. And that's pretty much it, right? This is pretty basic. It now inserts the user into our kind of local in-memory database. Now what is important to note here is that this is not thread safe, right? And we are going to fix this now. The reason for that is that we can access at the very moment, the user cache and write to it, but we can also read from it. So there could be somehow always a race condition. So let's just make this specific endpoint thread safe by declaring a so-called mutex. So let's create this mutex above our main function, and we are just going to say cache mutex. And then we make use of the sync module here, and this mutex is a read and write mutex. Now mutexes general can be in read mode or write mode, or like in this case in read and write mode. So it blocks all the reading and writing whenever this mutex gets locked. Now a mutex in general is really a safe way to synchronize your data kind of in a multi-threaded application, which in this case it could be our web server. And a mutex is a mutually exclusive flag, and this basically allows us to kind of block all the incoming threads whenever this mutex is locked. So for instance, when there is somehow a more heavy computation going on for writing to our user cache for whatever reason, then this mutex locks all the other threads, and whenever our lock is kind of unlocked, then the other threads continue. So with that in mind, we can pretty much make use of it, and the usage is really simple as well. We're just going to say here, whenever we insert something above that, because we insert now something to our database, we are going to make use of the cache mutex, and then we say lock. This basically locks the mutex now. And after that, we are going to say cache mutex.unlock. And now with this kind of locking functionality, it just locks the access, the reading access and writing access to our user cache. All right, and that's basically our create functionality. So let's just continue quickly with a retrieval functionality, because in the end, we obviously do want to retrieve the user data by ID from, for instance, a created user. So let's just do that by saying again mux.handleFunc, and then we are going to make use of the following pattern. We say get, because we want to retrieve data from our database, and then we are going to say users, and here we are going to make use of this pattern matching. So this is somehow a wildcard that just specifies that this is a kind of path parameter, which is user defined. So we can say, for instance, users/1, and then it should retrieve a user based on this ID, which is in this case 1. And for the handler function, we are just going to say get user. Let's keep it simple. Now, obviously this get user has to be created. So let's quickly do this here. All right, we got our get user and let's create the functionality. Now there is something new since Golang version 1.22, which is basically the path value function. Now this allows us to get the value of a path parameter. And in this case, we make use of the ID here. So because we've said in the beginning that our endpoint should listen, or the handler function should listen to this get endpoint, which has the path parameter ID in it, we can just say path value ID, and then we can retrieve the value of this path parameter. Now in the end, this returns a string and we are going to need to cast this to an integer. So let's just make use of the string conf package here, and we are going to say atoi, and as the function argument, we are just going to define the path value ID. And this now converts our ID string to an integer. Now things can go wrong because obviously ID can be an actual string with characters in it, and that's why we are going to need to handle this error here. So let's just say ID and error, and whenever there is an error, we're just going to return and in general again make use of the HTTP error method. We're going to write this error to our response writer, going to define the error function of our actual error here, and then again we just say bad request. And now we got our ID and now we can make use of it. Now you might now say that we just can simply read from our local memory database, right? And you are partially correct. So we can just retrieve the user here and let's just have OK to kind of see if the user or if the ID is actually in our local memory database. And we're going to say user cache at ID. And this partially works, right? Because again, this is not thread safe. Because obviously we read something from our database here. So let's just say cache mutex.rlog. In this case, we're just going to log the reading, only the reading part, not the writing part. And then we're going to say cache mutex.runlock. And now this computation here is thread safe. So with that in mind, we can just check if the user ID kind of exists in our local in-memory database. If the user does not exist, we're just going to return and create a new error here. Now we're just going to write the error again to our response writer. We say user not found, and then we define the status not found status code here. Okay, this was a lot of code, but we are not done yet. Obviously, we need to transform this user to a valid JSON representation, because in the end, we want to retrieve the JSON representation of this user for this endpoint. So let's quickly do that. Let's just name it J and R, because obviously there can be an error again while kind of marshalling or converting the user struct to a valid JSON representation. And in here, we're just going to say json.marshal. And here we say user. Now in the end, like I said, there can be an error. So if error is not equal to null, we kind of do the same thing that we actually did before. And instead of bad request, we are just going to say internal server error. Because the status now is not a bad request, obviously, because the user did everything correctly or the client did everything correctly. This is just an internal server error that basically means that we did something wrong in our code or in our marshalling in this case. Okay, and then in the end, we are just going to write the kind of marshaled user to the response writer, which in the end is just a byte slice, right? And this byte slice contains now all the information or the marshaled information or the kind of converted information in a valid JSON representation. And obviously we need to write the status code here as well. So let's just write the header here. And then we are going to make use of the status OK. This returns 200 and then it returns the JSON representation of our retrieved user. Now we are unfortunately not done yet because we still need to set the header to application/JSON to basically say to the response writers, so to the client, that our kind of response is in valid JSON or is in the JSON format. So we can say this by defining w.header, and then we say .set, and here we're going to say content-type, and then we say application/JSON. Okay, this was a lot of code, but this will now work. Now, to complete this kind of coding magic here, let's just create a quick delete functionality as well. So in the end that we can create, get and delete users. And again, we are going to create a handle function where we're going to say handle func, and then we say delete because we want to delete a user. In this case, again, we make use of the same path as our get endpoint. Now the only difference here, and that is really important to understand, is the actual HTTP method. So for the retrieval we have our get, and for the deletion we have our delete HTTP method. And then we are just going to create a handle function which we name delete user. Alright, let's quickly create this delete user function here. Going to again use the two path parameters. Now I'm going to speed through this specific function implementation because it's really straightforward. We're going to apply all the techniques we've learned in the last minutes. So we're just going to quickly get the ID here. Going to make use of this ATOI function where the path parameter is the ID, so we retrieve the value here. We're going to check again for an error. Now then we need to check if the user even exists in our local in-memory database. So for that we can just make a simple map lookup with existence check in one line. So we just say if, and then okay, we say user cache add ID, and if this is not okay, we're going to return an error here as well. Alright, that's pretty cool. And then in the end, we can just delete the user from our local in-memory database. Now for that, we are going to make use of the delete function, the native delete function in Golang. And obviously this allows us to delete a key value pair from a map. And you guessed it right, we need to log some things. In this case, the reading and writing part for our local in-memory database. So we're just going to say cache mutex .log, and in the end we're going to unlock this mutex again. And then last but not least, we're going to write in header, keep it simple, HTTP status no content. And that's basically it, right? We now got 3 endpoints for getting, creating and deleting a user. Whew, that was a lot of code. Let's quickly test our application here, right? If everything just works. Now for that, I'm going to make use of Postman here. And let's just say that we want to retrieve a user, because why not? So we haven't created any user yet. So let's send. And then we obviously get the error user not found. Now the reason for that is obviously that this user does not exist. And here we've basically made use of the user's endpoint, and then we've defined the path parameter, which is the ID of the user in this case. So let's quickly create a post request to our user's endpoint. Now this is a post request, and in here we have a body which is of type JSON. So we define a JSON body, and in here we are going to say name, which is just a JSON tag in our user struct in Go, and we are going to say my first name, for instance, right? So if we send this, we obviously do get a 204 back, which just says no content, so this request was successful. Now let's quickly verify this creation here, because in the end, this GET request now should work. And there we go. We basically now get our 200, which was a successful status code with our retrieved user from our local database. And now in the end, obviously we want to delete this user. So let's say we're going to create a delete request with the delete HTTP method. Then we are going to define the path here, which is users, and then the path parameter ID, which is in this case 1, with no body. And then we are going to say send. And there we go. We again get a 204 no content. And if we try to get this ID again, it just says user not found. And that was basically it, right? And the code is really far from perfect because we can optimize a lot of things here. And also we can refactor a lot of things to make this code more scalable and more developer friendly. And in the end, if you want to do something more complex, for instance with middlewares or something like authentication, then obviously it makes sense to use a third-party dependency. However, I believe that this video here and this code here gives you a good starting point for your own web server to basically enhance it and to make it more beautiful. And if you're wondering what structs are, because we've used them quite extensively in this code, then I highly recommend watching this video here, where I fully explain everything you need to know about structs in Golang. Anyway, thank you so much for watching, have a lovely day, and bye bye.